All right, so let's now continue our discussion. Let's just wait a second. All right, so again, before we continue our discussion, you guys have a question so far or clarification? Or any curious questions? All right, so how about you guys answer? If you don't have a question, then just type no question, sir. And if you have a question, so you may also use your mic or you can just simply type it in our chat box. So just for me to be able to know whether you are already there or whether you're there or not there. Okay. So any question?
None, sir.
All right, it's a good response. Quick
None,
and
sir.
short. How about the others? So none.
None, sir.
None po.
All right, it's good.
None, sir.
Para lang alam ko na nandyan kayo. Okay. So just respond that if you don't have a question, then answer. Okay. If you have a question, then ask it right away. Okay. All right. So you guys can see my screen now, right?
Yes, sir.
Yes, sir.
All right. So we've stopped right here. So let's now continue. So the next one is frequency distribution. So to make it short, frequency distribution is kind of similar with the weighted mean. Okay. But in here, in frequency distribution, we use this one for frequent user or for more or for larger collection of data. Okay, so in here, we're not going to use raw data. So what is raw data? So it is a data that have not been organized or manipulated in any manner are called raw data. And usually raw data is ranging from 50 and above. Okay, so it's not just small. Well, in some cases, it's small, but mostly it's ranging from 50 and above. Okay, so a large collection of raw data may not provide much readily observable information. So as you can see, we have a very large data, I think 5, 10, 15, 20, 25, 30, 40, 40 counts of data. So just by looking at it, okay, just by observing it by 2 minutes, so you won't be able to get uh, a lot of data or a lot of assumptions. Unlike if you only have 5 datas, so you already know or you can already calculate the mean, the median, the mode, and so on and so forth. But in here, it's kind of difficult to see or to know what is the mean, the median, and then the mode. Okay, so as a solution for that, we're going to use a frequency distribution. Okay, so it is a table. A table lists observed events and the frequency of occurrence of each observed event. So it is often used to organize raw data. Okay. And for instance, consider the following table, which lists the number of laptop computers owned by families in each of 40 homes in a subdivision. So we have 40 homes, and then we made a survey. Okay, and then let's say some households has 2 laptops, some doesn't have a laptop at all, some has 1 laptop only, others have 7. Wow, this was a rich family. Maybe all of the people in that house has a laptop, and then some has 5, and so on and so forth. Okay, and then here's now our frequency distribution. So how do we create a frequency distribution? So as you can see, we have 2 columns. The first one is the observed event, numbers of laptops, computers, or say we can denote that one as our X or as our data. So as you can see, we have 0 to 7. So I will explain later on how did we get that 0 to 7. And then the second column is the frequency number of households. Okay, wherein 5 household has 0 laptops, 12 households has 1 laptop, 14 households has 2 laptops, and so on and so forth. So in that, we could say that this is the frequent or it occurs 5 times that there is no laptop. It occurs 12 times that there is only 1 laptop. Okay, and then if you're going to add all of those, you will get the same counts of households. Okay, which is 40. All right. So how did we get this 0 to 7? So as you can see, we've only get, okay, it's very simple. We've only get the smallest number, which is 0, and then the largest number, which is 7. All right. So from here, as you can see, there is no 6, right? So try to check. Is there a 6 in here?
None po.
None. So as you can see, we've also listed 6 in our frequency distribution. So the hint here is just get the smallest and then add it by 1 or increment it by 1 up to the maximum or the largest number, which is 7. So that is why we have 0 to 7. So as you can see, even though there is no 0 households that is or that has 6 laptops, we've also included it here. Okay, just put here 0. It won't affect your answer at all. Right? So that's how we get, or that's how we get this first column. Okay, and for the second column, just count it. So 0 occurs 5 times. So let's try to verify it. So 1, 2, 3, 4, and then 5. Okay, and then for 1, it occurs 12 times. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that's how we or how we get this one, the frequent numbers of the households. All right. So I hope this one's clear. So this one is the data that we're trying to get, which is ranging from 0 to 7, and then how frequent that data occurs. Okay. So as you can see, 14 households has two laptops, or it's like the highest count of households, wherein mostly in each household there's two laptops. Well, it's very common. Maybe it's using by the parents, and then the other one is the for their son or for their daughter. Okay. All right. So the formula for a weighted mean can be used to find the mean of the data in a frequency distribution. So the only change is that the weights, W1, W2, and so on and so forth, are replaced with frequencies F1, F2, F3, and so on and so forth. So this procedure is illustrated in the next example. Okay, so as I'm saying a while ago, this weighted mean, or the weighted mean that we discussed a while ago, is the same or kind of similar with the frequency distribution. Okay, so you will know later on why. All right, so let's now have this example, okay, for our frequency distribution. So the question is, find the mean of data displayed in a frequency distribution. So we're now going to get the average, okay, numbers of laptops on each of those households using a frequency distribution. Okay, so as you can see, we still have the same data in our first column and then same data in our second column. And here's the total number of those uh, data on the second column. All right, so here's the solution. So mean is equal to the summation of x times f divided by the summation of f. So as you can see, if you're going to relate this one on the weighted mean, so before we have x times w and then divided by summation of w. So in here, you just simply replace the word or the letter or the symbol W into F, right? So from weighted, okay, or from weight to frequency, okay? So in here, here's our first data cycle and then up to the seventh data. And then on how many times that data occurs. So 0 times 5, 1 times 12, 2 times 14, and so on and so forth. So you must also include this one, even though we already know that the result of 6 times 0 is 0. So for the sake of completing the solution, so you must include this one. And then divide it by the summation of frequency. And then as you can see, this is the summation of the frequency, which is 40. So just put here 40. So 79 divided by 40 is 1.975. So we can round this one up into 2, wherein in those 40 households, the average count of laptops is 2. So most of them is using 2 laptops. All right. So the mean number of laptop computers per household for the homes in subdivision is 1.975. Okay, so any questions so far?
None po.
All right, so how about the others?
Answer.
All right,
Answer.
then that's good then. All right, so let me just pinpoint the difference between the weighted mean and then the frequency distribution. So weighted mean is like more on the grading system, or if there's a category wherein some data is much more important than the others. So we use the weighted mean, okay, because they have weights on each data. But for frequency distribution, so mostly this one is used for people, wherein just how many times that data occurs than the others. So just count it and then just list it, and then count again the others and then just list. Okay, so same process actually if you have this frequency distribution table. All right. All right, so moving on. So again, as usual, after this example, we're going to have a quiz on the frequency distribution. So uh, actually, this is like a bonus already. So instead of giving you guys a raw data like this one, I already gave you, okay, I already gave you the frequency distribution table. So this is super easy now. So it's like you can consider this one as the weight instead of the frequency. But of course, you have to change the W into letter F. And then here's the total frequency. Okay, so I'll be leaving this one to you guys and then just answer this one on the canvas later on. All right, so the next one is measures of dispersion. So under measures of dispersion, I think we have three. So yeah, three: the range, standard deviation, and then the variance. So first is the range. So this is the most simplest form in getting the dispersion. So what is the range? Okay, so to make it simple, let me give you a short definition of the range. The range is like the range, okay, or the distance between the smallest number or the smallest data to the largest data. So let's say we have the smallest is 1 and then 10. So their range is 9. So how did we get 9? Because, for us to be able to get the range, just get the largest data and then subtract it to the smallest data. So 10 minus 1 is 9. So the range between the smallest and largest is 9. So this is similar here. And before we go or before we dive into that example, let me just give you that why we get or why we are getting such range in statistics, because range is representing the margin of error, okay, or the accepted error in a certain say machine, okay. So actually they always use this one for products. So why for products? Because as we all know, some products are made by machines, and then for us to be able to check whether that machine is working properly or no, so we have to get the range. So what is that range? We're getting the largest that it produces to the smallest that it produces. So if it has a high range, okay, or it has a wide distance or large range, then meaning that is not good. That's an implication that your machine is not working properly. But if we have a minimal range like 1 and below, 1 is actually accepted and below is much more better. So if you only have a range of 0.5, 0.30, that's already super small. Okay, it's already good, meaning your machine is already working perfectly. So of course there is no such perfect thing. We still get a slight error, but if it's slight only, then that's okay. But if it's more than one, then that is not good already. Okay, so let's now go in here. So in the preceding section, we introduced three types of average values for a data set: the mean, median, and then the mode. But some characteristics of a set of data may not be evident from an examination of averages. So as you can see right here, we have two machines wherein we've solved for the average or the arithmetic mean, wherein both of them has the same answers, even though both of them has different data. So as you can see right here, mean is not effective anymore. Okay, it's not good to use with this one. So for instance, consider a soft drink dispensing machine that should dispense 8 ounces of your selection into a cup. So the table below shows the data for the two of these machines. So as you can see right here, let's say we have a machine one wherein for the first cup, it dispenses 9.52 ohms. Second cup is 6.41 ohms, which is not good, for as a customer, I will uh, I will tell the owner that your machine is not working properly. But if it's 9.52, which is higher than 8 ohms, okay, as a customer, of course, it's working perfectly. It's more than the amount that I am asking for. Okay, it's more than 1.52 ohms. But if you're getting less than 8 ohms, like you can notice it right away that, oh, this one is not 8 ohms. I can say that less than 8 ohms, okay? Because you already have your markings, maybe because you always buy a soda, okay? And then some are 10.07, which is, overspeeding the cap already. 5.85, which is super slow, super small, which is, the customer will complain for that one. And then we have 8.15, which is kind of okay, since 0.15 is not that noticeable. And then as you can see right here, uh, we have two customers that will complain because they've got less than what they are or what they are expecting to get. But on the other side, okay, as you can see, we have 8.01, 7.99, 7.95, and then 8.03, and then 8.02. So this one's like working perfectly. So it is doing its job. So 7.99, yes, it's lacking 0.01. But as a customer, we won't be able to notice that one anymore, okay? Especially that's a liquid. So we don't know whether this one is 8 ohms or less than 8 ohms. And then some are 7.95, which is also good, still good. So as I said a while ago, if it's less than 1, then that is good. But if it's more than 1, then that's already noticeable. Okay. And then as you can see, both of them have already result wherein an average of 8.0 and then 8.0. Why? Because it's a machine. We put an exact amount wherein the machine should divide it by, let's say, or should dispense it for 8 ohms. 8 ohms, 8 ohms, 8 ohms, 8 ohms, 8 ohms. Okay. But if it's, dispensing not properly, like this one, it dispensed 10.07. Of course, the other cup will not be sufficient anymore because you've already put the 2.07 on the other cup, wherein supposedly it should be exactly 8. All right. So that is now where range will be going into use, wherein we're going to get the margin of error. So in here, if we're going to get the range of the number one, so 10.07 is the highest, and then 5.85 is the lowest. So again, just get the largest and then subtract it to the lowest data. So 10.07 minus 5.85, what is the result? What is our range in machine number one?
Sir, pwede pa kayo ulit?
What is our range in machine number
4.22.
one? What?
4.22, sir.
4.22. So as you can see, it's more than 1. So 4 is 4 times than the accepted range or the accepted machine error. So wherein we could say that machine number 1 is not working properly, right? How about for machine number 2? I think I gave a quiz on this one. Find the range of numbers. All right, all right. So we will not answer number 2. Yeah. So it's good that I remember that I gave this one as your quiz for this for the range. Okay. So as I'm saying a while ago, so range is the set of data values is the difference between the greatest data value and the least data value. Range is like the margin of error, right? So as an example for the number one, okay, so we've already answered this one. So what is the range for the number one? So 10.07 minus 5.85 is 4.22. Okay. And then, of course, right after this example, we have quiz. Okay, we're going to get the range of machine number 2. Right?
Sir,
Any questions so far?
sir, wala po ako naintindihan sa sinabi niyo.
What?
Wala po ako naintindihan sa sinabi niyo.
All right. So let's go back. So what part?
Hindi po, yung sa last part lang po.
This one?
Yung
Or-
kakasabi niyo lang po.
Mahirap nang alalahanan kung ano yung sinabi ko. Anyway, so as I'm saying, we have already answered this one. Machine number 1. Okay. Find the range of the numbers of ounces dispensed by machine 1. We're in 10.07 or the largest data minus the smallest data, which is 5.85. So gets mo na to, which is 4.22 ohms.
Yes po.
All right. And then right after that example, of course, you're going to have a quiz. But this time, you're going to calculate the range on the machine number 2. Hanggang dun lang naman tayo. Okay na ba? Or may kulang pa? Same process, okay, but just a different number.
Okay na.
Hello, Mr. John Francis. Are you still there? Just would like to confirm whether you already get it or no.
Okay po. Okay na po, opo.
Okay.
Nagets na po. Salamat
Okay,
po.
so waiting for your response. Anyway, so again, this is our example, which is 4.22 on. So this is super easy. Okay, just by looking at it, you already know what is the answer. Okay, so just get the range for the machine number 2. Next one is the standard deviation. So, hindi ko na ito babasahin. Okay, bibigyan ko na lang kayo ng short discussion. So, range might be not that reliable, okay, because we're only getting the largest and then the smallest number. So, the other one that is not that, or much more reliable, okay, say much more reliable than the range, we have the standard deviation. So, why is this much more reliable than the range? Because instead of, solving for the largest and then deduct it by the smallest, in standard deviation, we are calculating it one by one. So every data is being calculated, okay? So all of the data matters in this standard deviation, okay? So this deviation is actually represented by x minus x bar. So this one, x minus x bar, is the deviation from the average of this number or of this data, okay, to the expected result. So as you can see, it has a deviation of 0.01, wherein these deviations, okay, yung mga yan, 0.01, 0.05 hanggang 0.02, those are our margin of error. So again, more than, less than 1, okay, is okay. So meaning, your machine is working properly. But if it's more than 1, let's say we have a standard deviation of 1.25, 1.30, meaning that machine is not working properly anymore. Okay, it's already very noticeable for the customers. Okay, so let's say, yan yung mga na-calculate natin. Okay, this one actually came from machine number 2. As you can see, 8.01, 7.99, and until 8.02. And then we just get the arithmetic mean. So, I think very obvious naman na dito, x minus x bar. So x is the data, and then x bar is the average or the arithmetic mean from that sample. Okay, wherein add those 8.01 until 8.02, then you will get a certain number, and then divide it by the counts of data. And then as a result, you will get 8 as the average, okay, or as the arithmetic mean. So moving on, okay. Isa pa pala, second one is the sum of deviations. Okay. So for you to be able to check whether the deviations that you're getting is correct or no, So you must have a result of 0. So why 0? Because those are your margin of errors wherein yung iba napunta doon yung 0.03, yung iba naman nabawasan na ng 0.05. So as you can see, yung kulang dito, nadagdag dito. Yung nadagdag dito, kulang dito. Parang ganun lang. So that is why it should be equal to 0. Right? So moving on, we have two ways to solve. But in fact, parang kwan lang naman to. Parang kapag population, you should use this one. And then pag standard deviation, I mean pag sample, standard deviation, you should use the other one. So for population, okay, we have this symbol. So I forgot the name of this symbol. Kalimutan ko talaga. Anyway, this is the symbol for the population. And then this is the symbol for the sample. And then again, if it's in population, so the symbol for average is mu. Okay? So ito yung symbol for average ng population. And then if it's the average of the sample, okay, it is the X bar. All right, so I hope you already familiarize their symbols wherein same process lang naman yung pagkuha natin ng average but we're using different symbols. So mu and then X bar. And then as you can see for the population, you have to divide it by the counts of data, which is n. Okay, and then for the sample, you have to divide it by the count of data, but you have to deduct 1 on the counts of data. So n minus 1. So as you can see, the only difference is this one and the unit symbol for the average. Then anything else is the same. All right. And one more thing is for the standard deviation of the sample, we represent that one as for letter S. Okay. And for population, we use this symbol. All right. So without a further delay, let's now start with the steps on how to compute for the standard deviation. So first one is determine the mean of the n numbers, which is you already know how to get that one. Okay, we've already done this one many times. And then we've also done this one in the range. So from that, you already have a basis on how to get the mean of that certain numbers. And then for each number, calculate the deviation or the difference between the number and the mean of the numbers. So for step number 2, we also already did this one, just like this. Okay, so in each data, we get the difference. Okay, so 8.01 minus 8 equals 0.01, and so on and so forth. Right? And then third one is calculate the square of each deviation and find the sum of these square deviations. So this one now is quite difficult to explain because I don't have a figure to show to you. So later on, I will show to you how this step number 3 is done. And then if the data is a population, then divide the sum by n, okay, which I've said a while ago. Use this formula or divide it by n for population. And then for sample, divide it by n minus 1, which is this one, right? And then lastly, once you're done in dividing that one under corresponding divisor, so find the square root of the quotient in step number 4. So this is now where the square root is being done. Okay, once you're done with the solution or the result on the inside, so you may now square root the result. So that's how we get the standard deviation of a certain data. So without a further delay, let's have an example. So find the standard deviation of this example. So 2, 4, 7, 12, 15. Okay. So find the standard deviation of this sample. Okay. Okay. So again, step number 1 is get the mean. So again, just add all of those numbers or the summation of those data and then divide it by the counts of the data. So 1, 2, 3, 4, 5. So divide it by 5. So 40 divided by 5 is equal to 8. And then step number 2, for each number, calculate the deviation between the number and the mean. So just subtract your mean from the data. So 2 minus 8 equals to negative 6. 4 minus 8 is negative 4, and so on and so forth. Okay? And then, if you're going to add those, you should get a standard deviation of 0. Okay, just for you to be able to check that your calculated standard deviation is correct. Okay, and then step number 3. So just as you can see, this is our data, and then this is where we done, or that this is where we did, or this is where we calculated this step number 2. This is now our step number 3. So just calculate the square of each deviation is in step number 2. So if you're going to go back on the formula, so this one, this is squared. So whatever is the result in here will be squared. So that is now step number 3. So once you're done with this one, divide it by n minus 1 or divide it by n. So depending on the uh, question, if it's a sample or a population. All right. So step number 3. So here's their result. So as you can see, even though we have a negative number, it will become positive. So all of those will become positive. And then third one that you need to do in step number 3 is the sum of the squared deviation. So all you need to do is add those squared results. So you will get 118 just by getting those or the summation of those results. And then step number 4 is of course dividing it by its divisor. So if it's sample, then divide it by n minus 1. But if it's population, then just divide it by n. But in here, since we have a sample, so we have to deduct it by, I mean, divide it by 4. Okay, so it should be n minus 1. All right. So 5 is our total. So minus 1 is 4. So as you can see right here, our calculated result on the this one, the squared deviation is 118. So just divide it by 4 and then you will get 29.5 as a result in step number 4. Then whatever is the result in step number 4, just square root that one. So if you're going to go back on the formula, it is now the step number 5 that we are dealing with. This one or this square root. Okay. So going back here, so just square this one and then you will get 5.43. So as you can see, this is the standard deviation for the or for that example. All right. So are we clear so far?
Yes, sir.
All right. So actually, we have two ways to do this one. So you can do it step by step, or you can do it in one-time shot in your calculator. So I highly recommend in using the step by step for now. And then once you're, let's say, sure on the things that you're going to do, so you can now do it one time or one shot in your calculator. Anyway, so of course, right after your example, you're going to have a quiz. Okay. So just check this one on the canvas later on to answer what is the standard deviation of this data, right? And then another example using the standard deviation. So to make it short, we have three companies, okay, Ever So Bright, Dependable, and then Beacon. So all of them has, of course, different data when it comes to using a battery. So 6.2, 6.4, 7.1, and so on and so forth. So it is now asking us what is the most reliable when it comes to the usage of your battery. Okay, so let's say a double A battery. So we're expecting 2 hours of usage, but if we've only got 1.30, let's say 1 hour and 30 minutes, then that's not good. But if it's more than the 2 hours, let's say 2 hours and 10 minutes, then that's good. Okay, so in here we're trying to see what is the company or what company is uh, creating or producing uh, like a consistent, okay, battery. Okay, so let's say if we are expecting 8 hours, then it should be, let's say, 7.9 or 8 point something or 8.10. Okay, all right. So for you to be able to show their answers, so here's the one-time shot on the calculator. All right, so 6.2 minus 7. So 7 is our mean. So just deduct it on every data. So 6.2 minus 7, 6.4 minus 7, 7.1 minus 7. And then just add all of those. And then divide it by the uh, average, which is 7. Okay, so since this one is sample, so you don't have to subtract 1 anymore. Okay, so just put there 7. Am I correct? If it's sample, ah, if it's sample, you should put here, or it should be deduct by -1. I think the one that we've used here is a population. So let me just check. For example, used on the deviation produces on should be tested. So, shown table according test.